Hello and welcome to the United Learning Walking Talking mock. This walkthrough is for paper 2 on the foundation tier paper for the November 21 series. We'll be going through question 1 to 20, 27 and 28. In total this will be worth 54 marks. This is a calculator paper, so wherever possible use a calculator and show you're working out. In your exam you'll be allowed to use an exam aid in the form of a formula sheet, so wherever possible I will reference the formula from the formula sheet where I can use it in a question. Okay, question 1. Write 31% as a fraction. Now percent means out of 100, so in order for us to write 31% as a fraction we are going to write it over 100, so 31 over 100, and that's it. We don't need to simplify this, and we can't simplify this anyway because 31 is a prime number, so we'll leave the answer like so. Okay, question 2, change 3 meters into centimeters. Now in order for us to do this question we need to know our unit conversion from meters to centimeters. We should know that 1 meter equals to 100 centimeters, and to scale that up to 3 meters I'm going to multiply that by 3, so I'm going to on both sides here, and that gives us a value of 300 centimeters. So the answer to this question is 300 centimeters. Okay, so question number 3, write the following numbers in order of size. Start with the smallest number. So we're going to start with the smallest number and increase to the largest number. Now there's 2 methods of doing this question. The first is to compare the digits in each of the place value columns for each of the numbers, so we can order them from smallest to largest, or we can change the magnitude of all these numbers so that they're easier to compare. So we'll start off by method 1, which is to compare the digits in each of the place value columns, and I'm going to first start by writing the units column down for each of these numbers. So each of these columns are the units columns in each of those numbers. Now clearly from here we can see that 2 of those numbers are larger than the other 2. So these 2 are larger than the 2 that I'm going to highlight in orange, and that's because the 2 highlighted yellow have the digit 1 in the units column, and the 2 that I've highlighted orange have a 0. So the orange ones are smaller, but at the moment from the first digit in the units column I can't compare, I can't tell which of the 2 orange ones is the larger one and which is the smaller one. So I'm going to move on to the next column, which is the 10th column, to compare, see if I can use the digits in that column to tell me which is the smaller and which is the larger. So you can clearly see here I've got the digit 1 in the 10th column and I've got the digit 2 in the 10th column in that number, so I can write down from here the smaller number, which is 0.12, and the larger number, which is 0.21. Now I can compare the 2 I've highlighted yellow in the same way. So again I'm going to write down the 10th column in each of these numbers, and I can identify the 10th digit here is 0, and the digit in the 10th column here is 2. So out of the 2, this one is the smaller one and this one is the larger one, or the largest one. So my next 2 numbers here will be 1.02 and 1.20. That's method 1. If you didn't want to use that method and you opted for a different method for this particular question, you could have changed the magnitude of the numbers. Now we can see that they're all 2-digit numbers. Numbers to 2 decimal places. So what we can do is multiply each of these numbers by 100, so we can compare the magnitude. So I'm going to multiply all of these numbers by 100. This here becomes 102, that becomes 12, that becomes 120, and that becomes 21. And from here we can quite easily see which one's the smaller numbers and which one is a larger number. Here, this one is the smallest number. We're going to be careful to write this value and not this value. You do not want to write 12. When you order this, you want to write 0.12 as your smallest number. Then your next larger number is 21, so you want to write the original number down, which is 0.21, and then 1.02, and lastly 1.20. And that's your list done. Okay, so question 4a, simplify m plus m plus m plus m. Here I'm adding 4 lots of m. If I'm adding 4 lots of m, that's 4m. Question B, simplify 12p divided by 4. That's this 12 divided by 4, which is 3, and that's 3 lots of p. Okay, so question number 5, the diagram shows a rectangle. And I have a diagram of a rectangle that is 35 meters in length and 20 meters in width. Then it says, on the centimeter grid below, draw an accurate scale drawing of this rectangle. Use a scale of 1 centimeter to represent 5 meters. Now on the centimeter grid, we know each of the lengths is 1 centimeter by 1 centimeter, and we're going to need to use the scale that's been given here to convert the dimensions of that rectangle so we can draw it on this grid. So to do that, for the length, I'm going to do 35 divided by 5. That's going to be 7 centimeters long, and for the width, that's going to be 20 divided by 5 to give me a length of 4 centimeters. Now I need to draw this rectangle on the grid below. So 7 centimeters, if I've got a centimeter grid, I'm going to draw 7 lengths, so 7 of these smaller lengths, 1, 2, 3, 4, 5, 6, 7, and the width is 4 centimeters, so that's 4 of these little lengths, 1, 2, 3, 4, and now I can draw the rest of my rectangle. I would suggest that you use a ruler for this, not draw it freehand like I am, as I don't have the option of a ruler. Okay, that's the question done. Okay, question 6, here's a list of whole numbers from 21 to 30. Below here I've got a list of numbers from 21 to 30. Question A, from the list, write down a square number. Now a square number is the product of a number that's multiplied by itself. So for example, 1 squared, which is 1 times 1, is 1, so 1 is a square number. 2 squared is 2 times 2, so that's 4, and 4 is a square number, and so on. So if I list my square numbers, 3 squared is 9, 4 squared is 4 times 4, which is 16, 5 squared is 5 times 5, which is 25. Now in this list I can see that I've got 25. Sorry, 25 is here, so I can write 25. Now just to check that I don't have any more square numbers, I'm going to work out 6 squared, which is 36, and that's a number that's not on this list, it's off the list. Question B, from the list, write down a multiple of 8. Now multiple is just a number in the times tables, so I'm writing a number that's in the 8 times tables, that's in this list. So if I list the multiples of 8, that's 8, 16, 24 and 32. I don't need to go above 32 because I don't have numbers in the list above 30. I can see that 24 is a multiple of 8 that's on this list. So the answer to that question is 24. Okay, question 7. A baker has 3 bags of flour, A, B, and C. Bag A and bag B contain the same amount of flour. Bag C contains 940 grams of flour. In the 3 bags, there is a total of 2,500 grams of flour. Work out the amount of flour in bag A. Okay, so to start off, I know that the 3 bags have 2,500 grams of flour altogether. So that's bag A plus bag B plus bag C equals to 2,500 grams of flour. Now, I've also been told that in bag C, I've got 940 grams of flour. And I've also been told that bag A and B contain the same amount of flour, but I'm not sure how much. So what we're going to do is we're going to assign X. We say X represents the amount of flour in bag A, not sure what that is. And bag B also has the same amount of flour, so that's also X. And C, I know how much that is, that's 940 grams of flour, and that's all equal to 2,500 in total. Here I've created an equation which I can solve. I'm going to start by collecting like terms here. So X plus X is 2X plus 940 equals to 2,500. I'm going to take 940 from both sides to start solving it. So that leaves me with 2X equals to 1,560. And now I'm going to divide both sides by 2 to give me X is equal to 780 grams. So that means in bag A, I have 780 grams. In bag B, I have 780 grams. And in bag C, I've already been told in the question, but I have 940 grams of flour. So in bag A, I have 780 grams. Question 8. 5 students throw a dice. They each throw the dice the same number of times. The diagram gives information about the number of times the dice lands on each number. Work out how many times each student throws the dice. So for this question, I'm going to need to find the total number of times the dice was thrown and then divide that by the number of students that threw the dice, in this case 5. Why? Because they each throw the dice the same number of times. So if I find the total and I divide it by 5 students, I'll find out how many times each student threw the dice. So to start that, I'm going to use this diagram. I know that on the x-axis I have the number on the dice, and on the y-axis I have the frequency. So this diagram is telling me how many times the dice landed on any particular number. So the dice landed on the number 1 6 times, on the number 2 4 times, and on number 3 5 times, number 4 8 times, number 5 7 times, and number 6 5 times. So in total, I'm going to add all these numbers up. So 6 plus 4 plus 5 plus 8 plus 7 plus 5, and that gives me a total of 35. So the dice was thrown 35 times. Now we know there were 5 students, and so to find out how many times each student threw the dice, I'm going to do 35 divided by 5, which is equal to 7. So each student has 7 throws. And so that's the answer. Question number 9. Alec needs to work out the value of 2 plus 3 times 4. He writes 2 plus 3 is equal to 5, and 5 times 4 equals to 20. So 2 plus 3 times 4 equals to 20. Alec is wrong. Explain why. Now, for any sort of calculation that we do in maths, especially when there's multiple steps, we know we need to use BIDMAS. So a calculation like this highlighted, we need to use BIDMAS. So if I write BidMass down, I know that if I have a calculation with any sorts of brackets or indices in it, I need to do that first, and then I need to do division and multiplication, and lastly I need to do any addition and subtraction. So Alec is wrong. I'm going to need to prove it by actually using BidMass on the highlighted calculation. So 2 plus 3 times 4, I'm going to need to do the multiplication first because that comes first in BidMass before the addition here. So 3 times 4 is 12, so I'm going to do 2 plus 12, and then 2 plus 12 is 14. So Alec is wrong. Explain why. Alec is wrong as he needs to use BidMass to do his calculation. Question number 10, write 17 as a fraction of 30. Okay, so this is a pretty easy question. 17 over 30, and that's a fraction. That's done. Question 11, reflect shape A in the mirror line. So this question we can do with a tracing paper. We can do this just as easy without a tracing paper. So to do it without tracing paper, we need to first locate the three vertices on this triangle. So that is vertex 1, vertex 2, and vertex 3. And we need to draw these vertices at an equal distance on the opposite side of this mirror line. So if I start with this vertex here, this is 2 lines or 2 centimeters or 2 squares away from the mirror line. So I'm going to draw this vertex on the other side of the mirror line at the same distance. So that's here. So that's the first vertex. And the second vertex, I'm going to draw this one. This is a distance of 3 squares or 3 lines away from the mirror line. So I'm going to reflect this on the other side by drawing an equal distance away from the mirror line. So that's 1, 2, 3. And the last vertex, which is this one, is a distance of 4. So I'm going to draw it a distance of 4 away from the mirror line. So 1, 2, 3, and 4. So that's my last vertex. I'm going to use a ruler to draw this. Unfortunately, I don't have a ruler, so I'm going to freehand it. However, you will need to use a ruler. And I'm going to label this A with a small apostrophe to indicate that this is an image of the object in the mirror line. Okay, so question 12a, work out the square root of 13.82 over 4.06. Write down all the figures on your calculator display. Okay, so for this question, you're going to have to type in this calculation into your calculator exactly as it is written there. And when you do that, it should look like this on the Casio calculators. And this is the exact answer you should have. So I'm going to write all these digits down on the answer line. So that's going to be 1.8449777205, and that's it. Part B, give your answer to part A correct to 2 decimal places. Now when we're rounding to 2 decimal places, I'm going to need the digit after the second decimal place in order for me to round. So I'm going to write this number out, 1.8449777205. 205. I'm going to identify the second decimal place. The second decimal place is here. It's the second digit after the decimal point, and I'm going to need to use the digit after it. So that's that 4 in order to help me around. All these other numbers I don't need. So I don't need the rest of these numbers. Okay, so the number after the second decimal place is 4, and the rule when rounding is if it's 5 or more, then you round up, and if it's less than 5, then you keep it the same. Okay, so here I've got 1.84, the digit after the line is 4, so I'm going to keep this 4 the same. So I'm going to write 1.84. That's it. That's my answer. Okay, question 13. RST is a straight line. Work out the value of x. Okay, so at point S, here, I have 3 angles, and those 3 angles are on a half turn, and we know that the angle sum of a half turn is 180 degrees, which means that those 3 angles around that half turn add up to 180 degrees. So to find the x, I can make an equation: x plus 75 plus 84 equals to 180. I can sum the 75 and 84, so I have x plus 159 equals to 180. And now I can take 159 from both sides to get x equals to 21 degrees. So the answer to part 1 is x equals to 21 degrees. Part 2, give a reason for your answer. Well, I did say earlier, and that was the angle sum of a half turn is 180 degrees. That's it. Okay, question 14. Nazima uses this graph to find out how much money she is paid for the number of hours she has worked. And below that we have a graph. Question A. How much money is Nazima paid for each hour she works? Okay, so if we look at the graph in a bit more detail, we can see that the x-axis represents the hours worked, and the y-axis represents pay. And if you look at the very end of the x-axis, we can see that it goes up to 5 hours. We can use this value of 5 hours and read the amount of pay she gets for 5 hours. And to do that, I need to find the value of pay for this point right here. Unfortunately, I don't have a ruler, but I can see that that point on the very end of the graph right here is halfway between 70 and 80. Now when you draw this line going across to the y-axis so you can read this number, you need to be very careful you do that with a ruler, and you need to make sure that that line is straight. But you can see here that for 5 hours she'll get paid £75. And to work out how much she gets paid per hour for each hour, we can do 75 divided by 5, and that is £15 for each hour that she works. Okay, continuing, last week Nazima worked for 36 hours. How much money was she paid? Okay, so we know she's worked for 36 hours, and we also know from the previous question that her hourly pay was £15 for each hour that she works. So the solution to question B is £15 multiplied by the 36 hours that she's worked. Now since this is a calculator paper, I will type this into the calculator, and doing so will give us an answer of £540. So that's the answer for part B, £540. Okay, so question 15, write the following fractions in order of size. Start with the smallest fraction. Now, in order for us to write these fractions in order of size, I can either do it with a method that's non-calculator, or I could use a calculator method. Now, since this is a calculator paper, I am going to be using the calculator method. To do this, I can turn all of these fractions into decimals using the calculator. And in fact, to make it even easier, I could turn all of these fractions into a percentage. So 5/8, I can first write it as a decimal or express it as a decimal on the calculator and multiply it by 100. So 5/8 as a decimal is 0.625. And if I times that by 100, I get 62.5%. And if I do the same thing for the next one, as a decimal, 2/3 is 0.6 recurring, and if I times that by 100, I get 66.6 recurring percent. And then 4/9 is 0.4 recurring, then timesing that by 100 is 44.4 recurring percent. And then 3/5 finally is 0.6, and timesing that by 100 to make that into a percentage is 60%. So similar to how we did the question earlier, I think it was question 2, what we want to do is we can use the percentages to compare, but when we write our answer, we need to make sure we use the original numbers. So comparing the numbers or percentages that I've just highlighted, we can see that 4/9 is the smallest number, that's 44.4%. So I can start by writing that one first. So that's 4/9, that's the smallest fraction. Then I can move to the next number. I can see 60% is the next smallest fraction, that's 3/5, and that's equal to 60. So we'll write down 3/5 as the next smallest, and then I'll move on. I can see that 62.5 is the next smallest percentage here, so writing that next, that would be 5/8, and lastly the final percentage is 2/3, and that's the largest, so I can write down 2/3 as my last fraction, and that's it, that's the answer. Okay, so question 16, the pie chart gives information about the color of each car in a car park. And here I have a pie chart. There are 135 black cars in the car park. Part A, work out the number of white cars in the car park. So from the question, I've been given this piece of information that there are 135 black cars in the car park, and I also know that the proportion that represents the black cars is a quarter. I know that because this is a right angle, which is a 90-degree angle, and the full pie chart is 360 degrees. So I know that this represents 135. So the total number of cars in this car park would be 135 times 4, and that is 540 cars. Now I know the number of white cars in this car park is represented by this sector, and this sector has a proportion of 80 degrees out of the full 360. So for that calculation, to work out the number of cars, I'm going to write 80 out of 360 as a proportion. So 80 out of 360 as a proportion, and multiply that with the total number of cars in the pie chart. So that's 540. Now if I type this into the calculator, I'll get an answer of 120 cars. Second part of the question, there are 50 grey cars in the car park. A car in the car park is picked at random. Find the probability that this car is grey. Okay, so if there's 50 grey cars in the car park, out of a total of 540 cars, the probability of picking a grey car out of the total of 540 cars is going to be 50 over 540, and we can leave the answer as 50 over 540, or we can type it into a calculator to simplify the answer, and if we do that, we'll end up with an answer of 5 over 54. Either answer, either this one or this one, is acceptable. Okay. Question 17. 60 people are asked if they prefer to text or to email their friends. 38 of the people are women and the rest are men. 15 of the men prefer to email their friends. 60% of the people prefer to text their friends. Complete the frequency tree for this information. Now, 60 has already been filled in on this frequency tree, and we know that 60 is the total number of people. We also know that 38 of the people are women, so that means I can fill this circle for women with 38. So we know there's 38 women. So that means to find the number of men, we can do 60 minus 38, which is equal to 22. So now we know there are 22 men. Okay, so the next bit of the diagram, the next bit of the information that we're going to use is that 15 of the men prefer to email their friends. So 15 of the men prefer to email their friends. So I'm going to add that to the diagram. So here's email after men, and I'm going to write 15 here. And we know that there's a total of 22 men. So if 15 men like to email, then that means 22 minus 15 gives us 7. So these 7 men prefer to text. Okay, so the next piece of information that we have is 60% of the people prefer to text their friends. That's 60% of the total. So if we look at texting so far, we can see that we have 7 people at the moment who are men who text. The rest of the people who text are women, but that represents altogether that represents 60% of everybody. So to work that out, what we need to do is to find 60% of 60, and in the calculator that's just 0.6 times 60, which is equal to 36 people. And we know out of these 36 people, 7 are already men. So the number of women that prefer to text would be 36 minus 7, which is 29 women. So 29 women prefer to text. Now to find the final number, which is the number of women that email, we know that this entire frequency diagram, or this frequency tree, needs to add up to 60. So if we add up 7, 15 and 29 and find the difference from 60, that will give us the number of women who prefer to email. So to do that, I'm going to do 7 plus 15 plus 29. That gives me a total of 51 people, and 60 people in total, so 60 minus 51 is equal to 9. So 9 women prefer to email. Okay, and that's it. Okay, so question 18. The incomplete table gives some information about the lengths of the planks of wood in Ben's workshop. Below that I have a table that has 2 columns. Length of plank in meters and the number of planks. So here I have 5 planks that are 3 meters long, 8 planks that are 2.5 meters long. I don't know how many planks are 2 meters long. I have 14 planks that are 1.5 meters long and 10 planks that are 1 meters long. The total length of these planks is 92 meters. Work out the number of planks of length 2 meters in Ben's workshop. Okay, so I've got this piece of information here. The total length of all the planks together is 92 meters. Now, if I start by working out the length of all the planks that I have in the table, I know that they all need to add up to 92. So whatever's missing must be the total length for the number of planks that are 2 meters long. So if I start with the first row, I know that I've got 5 planks that are 3 meters long, so I can do 5 times 3 to give me 15. So the planks in the first row are 15 meters long altogether. The second row, I've got 8 times 2.5. 8 times 2.5, I can put that in my calculator if I'm not confident with multiplying that mentally. And the answer to that is 20. I can't do this one, I'm not so sure, because I don't have the number of planks. The number of planks that are 1.5 meters in total, I've got 14 of those, so I'm going to do 14 times 1.5, and that will give me 21 meters. And finally, in the last row, I've got 10 planks that are 1 meter long, so 10 times 1 is 10. Okay, so I know that all of these lengths, including the one that's the row that's missing here, needs to add up to 92. So at the moment, I've got 15 plus 20 plus 21 plus 10. That equals to 66. In total, I know they add up to 92. So if I do 92, take away 66, that will give me 26. And that's the total length that these 2 meter length planks add up to. So I know that the total that this adds up to is 26. So I know each of these planks is 2 meters long. So to find my answer, I can do 26 meters of plank divided by the lengths that are 2 meters long, and that will give me 13. So I have 13 planks that are 2 meters long, and that's the question done. Okay, question 19. Rachel, Samina and Tom share £600 between them. Rachel gets 2/5 of the £600, Samina gets 1/4 of the money that is left over, and Tom gets the rest of the money. Tom says, I would have got more money if we had shared the £600 equally between us. Is Tom correct? You must show how you get your answer. Okay, so to start this question, we know that we've been given this information, and what we can do is share the money between Rachel Samina, and Tom as it's initially described in the question. So we know that Rachel gets 2/5 of £600, so I'll work that out. The calculation for that is going to be 2/5 times 600. I can type that into the calculator and I'll get an answer of £240. So Rachel gets £240. Now if I continue reading on, it says Samina gets 1/4 of the money that's left over. Okay, so 1/4 of the money that's left over. So initially we had £600, and I've just given 240 to Rachel. Rachel's taken £240 there. So if I do 600 take away 240, and that will give me £360. So there's £360 left, and Samina gets 1/4 of that 360. So I'll work that out next. So 1/4 times 600, and again I can type this into the calculator and I'll get an answer of 90. Okay, so Samina gets 90, Rachel gets 240. The final part, if I continue reading on, it says Tom gets the rest of the money. So Tom gets the rest of the money that's left after Samina's taken her £90 from the 360. So initially there was £360 left. I've just given 90 to Samina, or Samina's taken 90. That means that Tom has £270 left. Okay, so next part of the question, or what is Tom saying? Tom says that I would have got more money if we had shared £600 equally between us. Now if we share the £600 equally between Tom, Samina and Rachel, we can continue the calculation down here. 600 divided equally between 3 people, that means I'm going to divide by 3 and end up with 200. So each person will end up with 200. Does Tom get more money? Well, initially sharing it in this way, he gets 270, but then sharing it in this way, he gets £200. So no, Tom is not correct. No, Tom is not correct. He will get £70 less. Full stop. Okay, and we're done. Okay, so question 20 is all to do with the rules of indices. So the first one, A, simplify c to the power of 5 divided by c to the power of 2. I need to use the division rule, which says if I'm dividing two powers with the same base, I'm going to take the indices away. So that's c to the power of 5 minus 2. That gives me c to the power of 3. Part B, simplify d to the power of 4 to the power of 3. That rule is the power to the power rule, which says if I have a power and that's raised to another power, then I multiply the two indices. So in this case, this is going to be d to the power of 4 times 3, and that's d to the power of 12. So these are my answers for A and B. Okay, so question 27, solve x squared minus 7x minus 18 equals to 0. So here we've got a quadratic equation, and we know it's a quadratic equation because it has an x squared term. And when we solve a quadratic equation, we usually end up with two answers. X equals to something and x equals to something else. Now, the first step in solving this is to factorize this quadratic equation. To factorize, I'm going to need to use the sum and product method. So the sum and product method, I'm going to draw a t-table. I'm going to write product on one side and sum on the other, and I need to write down my sum and write down my product. Now the product is the number at the end, in this case that it has no x next to it, and that is negative 18. So the product is negative 18, and the sum is the term with the x, and that term, the coefficient of x, that's including the sign, so that's minus 7. Okay, now to find to factorize this, I need to find a factor pair that has a product of negative 18 but also has a sum of minus 7. Now, in order for me to do that, the easiest way is to just write down the factor pairs that make 18. So that's going to be 1 times 18, 3 times 6, and 9 times 2. These three factor pairs make 18, but I need to make negative 18, and I also need those two numbers to sum to minus 7. So I can start by using a process of trial and error. So I can say minus 1 times 18 gives me minus 18. However, minus 1 plus 18, it doesn't work because it doesn't give me minus 7. So that's not going to work. I can try another combination of the same factor pair. I can say minus 18 times 1 also gives me minus 18, and minus 18 plus 1, it doesn't work because it doesn't give me minus 7, so I can't use that. And through a process of elimination, I can come to the correct answer, which is minus 9 times 2 gives me minus 18, and minus 9 plus 2 gives me minus 7. So this is the pair that works. Okay, so once I found the pair that works, in this case it's minus 9 and 2, I can make two pairs of brackets and make that equal to 0, because remember my original equation is equal to 0. I can write x in both brackets, so x and x, and the number term that goes in the two brackets is, well, the first bracket I'm going to put minus 9, so that gives me x minus 9 in the first bracket, and the second bracket I am going to have x plus 2. So I'm going to write plus 2 in the second bracket. Okay, so now I've factorized it. I still haven't fully solved it. Remember, in order for me to solve it, I need two answers in the form of x equals to something and x equals to something else. In this case, I'm going to write the value of x, the answer of x is equal to the inverse of this number inside the bracket. So it's the inverse of this. So my first answer for x is that x is equal to 9, and my second answer for x is the inverse of whatever's in the second bracket, in this case the inverse of plus 2, and so that answer there is x equals minus 2. So my two answers for x equals to minus 9 and x equals to minus 2, sorry, x equals to 9, apologies there, and x equals to minus 2. So these are my two answers for x. That's it, question done. Okay, so question 28. In a sale, the normal price of a boat is reduced by 15%. The sale price of the boat is £272,000. Work out the normal price of the boat. Okay, so we know that the original price of the boat has been reduced by 15%. So whatever the original price was, we know that that represented 100%. We don't know what that original price is. That's what we're trying to find out. We do know though, after it was reduced by 15%, the value of the boat was £272,000. So after the boat was reduced by 15%, that percentage overall represents 85%, and that 85% of the original price is worth £272,000. Now to find the original price of the boat, I can do it in multiple steps, or I can do it in one step. For this question, I'm going to do it in multiple steps. So I'm going to find first 1%, and then from there I'm going to find the original 100%. So to find 1%, I'm going to divide the price that we have, the reduced price, by 85, because £272,000 represents 85% of the original price. So I'm going to divide this by 85, and if I pop that into the calculator, I can get an answer of 3,200. So 1% of the original price is 3,200, and to find 100%, I'm going to multiply that value by 100. So to get from 1% to 100%, I multiply by 100. So to get the final price, I also need to multiply that value by 100. So 3,200 times by 100. Again, I can do this in the calculator. However, I might not need to. That's going to be 3,200,000. So the original price of the normal price is 3,200,000, and that's the answer.